Okay, so in our example here, we are wondering if the size of the bowl affects the amount of ice cream that people tend to scoop when they serve themselves. And most people hopefully would suspect that the bigger bowl, you're going to get yourself more ice cream, right? So they did an experiment. People were randomly given either a 17-ounce or a 34-ounce bowl and then invited to scoop as much ice cream as they liked. Okay, so we have the data here in the table. We've got the bowl size 17 ounces, the mean, standard deviation, and size of the sample, and then same thing for the 34-ounce group. Okay, so we know first off that this is means, right? So we know means. Oops, let's go back. There we go. We know it's means. We know we have two samples. And we also know that these two samples are independent because they were randomly assigned to the two groups, and there's no reason to suspect that there is a link between any one of the data values in the 17-ounce group and a particular data value in the 34-ounce group. Okay, so these are independent samples. So all those things together mean that we are doing a two-sample t-test for means, mainly because we don't do z-tests, right? And so when we write our null, we're going to say, hey, I've got my 17-ounce bowl and I've got my 34-ounce bowl, and the null would be that the mean amount of ice cream scooped is the same for both bowl types, that there's no difference, that they're equal. And you are perfectly fine writing this as a difference, that the mu for the 17 minus the mu for the 34 is equal to 0, or you can flip the order, doesn't matter, right? Now our alternate, we're going to look the same, 17, 34, and now the question is, do we think it's more, do we think it's less, or do we just think it's different? Now again, don't look at the data here, look at the question, right? Because really we're supposed to set this up before we get the data, right? So does the size of the ice cream bowl affect the amount of ice cream people scoop? So there is no preference there's no suspicion that it's more or that it's less. Therefore, we're going to go with a two-tailed test, a not equal to. Okay, so we've got all our information, and we're going to do this with GeoGebra as much as we can. Right? So we know it's means, we know it's a difference of means, and we're not doing confidence interval, we are doing a hypothesis test, t-test. Okay, so 17 is going to be our first sample, 34-ounce bowl is going to be our second sample, and so our null is a statement that the difference is equal to 0, and our alternate is going to be a not equal to. And then we are going to put in all of our numbers. So I'm going to move this over here. So 5.07, 1.84, oops. Guess I got it there. There we go, 1.84, and 26 for our first sample, and 6.58, 2.91, and 22 for our second sample. Okay. And so we can see here that we have, first off, a degrees of freedom of 34.31, blah, blah, blah. That is not what we are going to use. We're going to use the conservative DF, which is an integer, right? And we have our t-score negative 2.104. So we've got a t negative 2.104. And we also are going to say DF, what is that going to be? So we're going to look at these two. Which is smaller? 22. Subtract 1. So our degrees of freedom is 21. Now, we should sketch this. The center would be the hypothesized difference of 0. Our actual difference, 5.07 minus 6.58. I think GeoGebra calculated that for me. No, of course not. But roughly speaking, negative 1.5. So here, x bar 1 minus x bar 2, not squared. Whatever, I can't get rid of that. There, we'll just do that. And so the p-value would be represented by shading, right? We're going to shade the area below that test statistic and the mirror image on the other side, because this is a two-tailed test, right? Now, our p-value is not going to be this 0.04 here, because we're not going to use this DF of 34.3. We are going to use a DF of 21. So we're going to go back to distribution. We're going to make sure we've got students selected, change our DF to 21. We're going to go left-tailed, and we had a test statistic of negative 2.104. And so we're going to take that 0.0238 and double it. So p-value 0.0238 times 2 for our p-value, because this is a two-tailed test. So we just found the left tail 0.0238, but so's the right, because it's the mirror image, right? So we're talking 0.0476. Okay, how does that compare with what it gave us for exact? It's a little bit bigger, not a whole lot, but enough for WebWork to say nope. Okay, so if I say, hey, your alpha level is 5%, what's your conclusion? You're going to say, well, that p-value is less than alpha, so I'm going to reject the null and say, yeah, the evidence suggests that the size of the bowl affects the amount of ice cream people scoop. So you can just restate the question. Evidence suggests, or you could say that the average amount for the two different bowl sizes is different. However, you know, there's a couple of options. So suggests the size of the bowl affects the amount of ice cream scooped. I'm going to leave it there. All right, that's it. There we go.